Hello, this is Jasmin again. Welcome to the second day of our virtual physics event with UMPO. Today's topic is physics of the very small. Yesterday we learned that physics is the study of the very big and of the very small. Today we are focusing on the physics of the very small. Let's start with a question. What is the smallest thing you can think of? Is it an ant or a grain of sand? This is what grains of sand look like under a microscope. We need to think smaller than that. Most of the sand in the world is made up of grains of a type of mineral called silica or quartz. Quartz is a molecule made up of silicon and oxygen atoms. The atoms in this picture are shown as red and white balls. See how many of them there are in the picture. Atoms must be really small in order to fit so many of them in a molecule. But are atoms the smallest thing there is? The word atom comes from the Greek word atomos, which means uncuttable, because the philosophers of ancient Greece thought the atom was the smallest thing there is. Everything we know and see and can touch is made up of atoms. But let's look at the atoms from the previous slide, silicon and oxygen. You can see that they both have smaller particles going around their center and a lot of particles stuck together in the middle. All atoms have this kind of structure, but the number of the particles that make them up changes depending on the atom. This means that even atoms are made up of smaller particles. The particles circling around the center are called electrons. Electrons are elementary particles. This means that they aren't made up of smaller particles, at least to our current knowledge. The center of the atom is called the nucleus. The nucleus contains two particles, the neutron and the proton. Both the neutron and the proton are made up of three smaller particles called quarks. Quarks, like electrons, are also elementary particles. We will now learn more about these elementary particles. So, this is our particle zoo. There are loads of different particles of different sizes and weights, and they all have different purposes. We are going to talk through some basic properties of different particles. Particles come in lots of different flavors, just like ice cream, and they all have different properties depending on what flavor you choose. We are going to focus on two main types of particles, force particles and building block particles. We'll start with the building block particles, which build up matter. There are two groups of building block particles, quarks and leptons. Let's look at both of these groups. There are 6 flavors of quarks: up, down, charm, strange, top, and bottom. The different flavors of quarks have different properties, and as you can see, they all look a bit different. Some of them are heavier than others and can point up or down. Quarks hate being on their own, so they always stick together either in pairs or in groups of 3. Remember protons and the neutrons from the center of the atom, or the nucleus. The up and down quarks form groups of 3 to form them. Now let's look at the other group of building block particles, leptons. Leptons prefer to live and travel on their own. Like quarks, leptons also have different flavors: electron, muon, and tau. They also have some super sneaky relatives called neutrinos, who move really fast and are really hard for scientists to detect. They are the ninjas of the particle world. The neutrinos are considered to have a very different flavor to the other 3 leptons. We already met the electron in the atom. The electron doesn't weigh a lot, and it circles the center of the atom, or the nucleus. The electron also carries charge, so when the electron moves through a wire, it creates electricity. The muon is similar to the electron, but it's a lot heavier. However, tau is the heaviest of them all. Now that we've learned about the building block particles, it's time to take a look at the force particles. Force particles aren't used to make up the things around us, but they do help us to do things. The Higgs boson was discovered 8 years ago in 2012 at the ATLAS and CMS experiments at the Large Hadron Collider at CERN in Geneva. The Higgs boson is important because it gives all the other particles their mass. Photons are bosons that don't weigh anything. They are the particles that help make light visible. The gluon is a boson that acts like glue and sticks particles like quarks together in the center of the atom, or the nucleus. The W and Z bosons cause nuclear decays and they help magnets stick together. So even though the force particles don't make things, they help the building block particles to build things. The force particles are also behind a lot of the things that we can see in everyday life, like electricity, light, and magnetism. Now that we've studied all the different types of particles, our particle zoo is complete. Did you know that scientists actually group the particles into this kind of zoo that they call the Standard Model? The Standard Model is made up of the building block particles, quarks and leptons, and the force particles that we call bosons. Do you already have a favorite particle? We are now coming to the end of our second day. Let's recap what we learned about the physics of the very small. Atoms make up all matter. The ancient Greeks thought the atom was the smallest thing there is. But we know now that even atoms are made up of smaller things called particles. The particles in our particle zoo come in many different shapes, sizes, and flavors. The particle zoo is divided into building block particles and the force particles. Building block particles can be quarks or leptons. Force particles are called bosons. The particle zoo is known to scientists as the Standard Model. So we learned quite a lot, didn't we? We will hear more about these particles in our Q&A session with a real particle physicist later today. One of our team members, Mary, will also show you how to make your own particle at home. Make sure you watch both of these videos after this presentation. Now let's see what we will do tomorrow. Tomorrow we will explore the physics of the very big. We will see what stars and black holes are. And we will also learn how we get rockets up into space. And how we make sure astronauts can land safely on the surface of the moon. Tune in tomorrow to find out more and learn how to make your own lunar lander. Thank you so much for joining us again today. We'll see you tomorrow. Bye!